I'm starting the recording. Yes, so as per kinematics, we were talking about motion along a straight line, and last time we saw motion along a straight line with uniform acceleration, etc. Right, so don't worry, we will discuss. I'm seeing some of your messages, etc. So we will be discussing all the applications of motion along a straight line equations that we derived last time, and we'll be seeing all of those things in a lot of detail, so don't worry about that. Okay. So let us start with a quick recap of the equations that we saw last time. So we saw that we talked about motion along a straight line. With uniform acceleration. So that uniform acceleration is E. So the initial velocity being given with the symbol U and the uniform acceleration being given with the symbol E. We saw the equations that we were able to derive that at some time or at some instant of time, P equal to T. We saw that we can determine the velocity, the instantaneous velocity V as U plus AT, and we can determine the instantaneous displacement S as UT plus half AT square. Okay. And what we have seen is that the first equation basically comes from the concept that this acceleration, which is delta V by delta T, instantaneous acceleration, is also the average acceleration. So it is V minus U upon total time. Because in general, we saw that your velocity versus time is a straight line graph with either a positive slope or a negative slope. So in both the cases, we saw that we can prove very easily that as long as your velocity time graph is a straight line, the slope of the graph at any point, the instantaneous slope, is the same thing as the slope of the line itself, which is nothing but V minus U upon the total time. And as far as the second equation is concerned, we saw that we can calculate displacement as the area under the velocity time graph. So once from the first equation we saw the velocity time graph looks like a straight line, then whether the acceleration is positive or negative, but just using the helping formula that area of a trapezium is half of sum of parallel sides into perpendicular distance, just by using that simple concept, we were able to derive the second equation that S is equal to UT plus half AT. Okay. Now the third equation, which was this, V square is equal to U square plus 2AS. This is not coming from some graph or some formula. This is just coming from equation 1 and 2. So for the third equation, what we do is, in equations 1 and 2, we just eliminate. Just hang on a moment. I'm getting some lag in my. So we eliminate time. Okay, I'm just sharing the screen with you again. Don't worry. Okay. So this is what we do to get the third equation. In equation 1 and 2, we eliminate time. Okay? So by eliminating time between the two equations, we get a relation between V and S. Okay, so here the relation is V versus S. That's your third equation. Here the relation is S versus time. That's your second relationship. And the first relation is instantaneous velocity versus time. So you have to also keep in mind that this is what we mean by geometry. Okay? So today we will see a number of applications of this and more about the graphs and things like that. But more importantly, we will start with some examples from the worksheet which I've given last time. Okay, so let me start with a review of worksheet number 2 in Kinematics. Right, so just turn to the worksheet and let's start with question 1 actually. So question 1 was about some kind of a graph. So given to you was the graph of position versus time. Okay, the x coordinate of the particle going along the x-axis. So that is nothing but position, right? So when we are talking about the x coordinate of a particle which is moving along the x-axis itself, we are talking about nothing but position versus time. Okay. So this was the graph given. Now the graph was like this. It was starting from x equal to 0. Okay. Then x is constant for some time. Then again x increases. And then finally x decreases and comes back to 0. Okay. And the values of x and relevant amount of time were given to you. So for example here, this value of x was given to you as 50 meters. Because the unit is given on top. This value of x above is given as 100 meters, so double of that. And correspondingly, this value of time here, somewhere here, this is given as 2.5, and the time is in seconds. Then this corresponding value of time over here is 7.5 seconds. And in between over here, this time is 10 seconds. Okay. And this time is 15 seconds. So this was all the information that was given to us systematically. And we have to find out the average velocity. Okay. So we have to find out average velocity from 0 to 10 seconds. And we have to also find out instantaneous velocity. Instantaneous velocity at t equal to then t equal to 5 seconds, t equal to 8 seconds, and again t equal to 12 seconds. So hope all of you have more or less been able to work out this question. Okay, so I'll just quickly relate what we have to do over here. So as far as average velocity is concerned, what is it? Average velocity is total displacement upon total time. Okay. So when we are talking about average velocity from 0 to 10 seconds, we are talking about displacement from 0 to 10 seconds divided by the time, which is 10 seconds. Now displacement from 0 to 10 is nothing but change in position. So it is the value of position at 10 seconds minus the value of position at 0 seconds divided by 10 seconds. Now you can see from the graph, in 10 seconds the position has reached 100 meters. So it is plus 100 starting from 0 of course divided by 10 seconds. So the average velocity should come out to be a positive quantity and it should come out to be plus 10 meters per second. Okay, so this is the average velocity, the answer for the first part, from 0 to 10 seconds. That's it. Alright, so I will just leave you to quickly understand this. Alright, now next thing we want to find out is the instantaneous velocity at t equal to 2 seconds. So as you know, the instantaneous velocity is displacement upon time for a small interval of time, delta t being very small. So in terms of graph, what is it? It is the slope of the graph of velocity versus time at that particular instant. So let's go back to the graph above here, and we'll understand very easily that the particular graph that we're talking about, that is this one. Now see here, in this graph, this time over here is 2.5. Okay. So 2 seconds will fall somewhere before that. Okay. So 2 seconds will, let's say, fall somewhere here. So if this is the moment 2 seconds, then we're talking about this point in the graph. So what is the slope over here? At this point, the slope is nothing but y2 minus y1 upon x2 minus x1. So you can see that it is 50 divided by 2.5. So that is 20. And it's a positive slope and it is 20 meters per second. Okay? So at whichever point of time we are finding the instantaneous velocity, we have to find the instantaneous slope at that moment. That is the concept that we'll use for having instantaneous velocity. Whereas for average velocity, we'll be using the formula. So for Bhaumik and others who might have joined late or whatever, just reminding you this is a recorded session, so I don't need to start from the beginning again. What I will do is I'll be giving you people the recording. Okay, so you can any part that you missed or in between also if there's connectivity issue, and because of that you are having any problems with this thing. What we call it, the in between you miss some part of the lecture. Don't worry about it. Okay, you will be getting the recording by end of today itself. Don't worry. Recording as well as the whiteboard notes. So you get full support about this. Okay, so this is the thing. Okay, so hope this part is clear to all of you. Now similarly, next we have to find the instantaneous velocity at this time here, which is given to us as 5 seconds. So 5 seconds, as you can see, is falling somewhere here. So at this instant, you can see it's a flat line, na? So the slope is 0. So that means the instantaneous velocity at 5 seconds, it is 0. So this answer becomes 0. The velocity at t equal to 5 seconds is 0. Whereas this answer we already saw earlier, the velocity at 2 seconds was plus 20 meters per second. That was the rate at which the particle was going at 2 meters at 2 seconds. Had it continued at this rate instead of stopping over here, this graph would have continued in this way. But what happened is at 2.5 seconds, the motion abruptly stopped. This is not a very physically sound situation because you cannot suddenly go from 20 meters per second to 0. You actually take some time to decelerate. But in this example, we're just assuming that 20 pe ja raha and suddenly it stopped, like it hit a wall or something and just got stuck to the wall. So something like that. And then similarly, we come to the 8-second one. So 8 seconds you can see is somewhere over here. So now you have to find the slope of this point over here. So the slope of the graph at this point. So just relate it with these two data points. This data point here and this data point here. So you can see the slope is y2 minus y1. So that is 100 minus 50 on the y-axis divided by x2 minus x1. So at this point, which I related, the time is 10 seconds, and at this point it is 7.5. So 10 minus 7.5. So you're back to the same thing. It is 50 divided by 2.5. So it is nothing but 20. So again, the velocity repeats itself at this interval. The instantaneous velocity at 8 is again plus 20 meters per second. Right. So hope this is also clear. Yeah, the part for 5 seconds, Yuvraj, is like this. Let's see, at 5 seconds, you can see the graph is where? The graph is over here. I'll just get. So at 5 seconds, this is this part of the graph. Okay. So if it is this part of the graph at 5 seconds, you can see what is the position. The position is constant. Na? So position agar constant hai, to velocity kaisa hoga? 0 hoga, because the position is not changing. You can see at 5 seconds, between 2.5 to 7.5 actually, what is happening? The position is remaining constant at 50 meters. So it's like, your particle started from here, reached 50 meters, and then just stuck at 50 meters for a duration of time. It did not move for another whatever, 2.5 to 7.5. So for 5 seconds, it's not moving at all. So at any instant during those 5 seconds, between 2.5 and 7.5, not only 5 seconds, but 5.5 seconds, 6 seconds, any of these instants, what's happening? The particle is at rest. Now the slope is 0. The slope is 0 at this point. What it means that the particle is at rest. But again, here the slope you can see is positive. So the velocity is positive. So you can see that the velocity is positive of the slope. And similarly now, why don't you people try out the 12 seconds if you haven't done it yet? Okay, I will put up the answer very soon. So just work this out. To help you, I'll show you that 12 seconds is somewhere over here. 12 seconds is the time somewhere over here. So now just figure out this part of the graph. This last straight line of the graph, which is there between this part, between 10 and 15 seconds, what's happening? The velocity is again constant. Yes, but it is what kind of correct, Sona. But it is what kind of velocity? It's negative because the x-coordinate, it is decreasing. So as far as the motion is concerned, how it looks, it starts from 0, reaches 50, it is constant there for some time. Then again it increases from 50 to 100. Then immediately after reaching 100, it starts coming back and it finally reaches 0 again at 15 seconds. Correct. So that is also, your answer is also correct. Good. So at the last data point over here, you can see that the slope at this point, we're talking about the slope of that downward pointing line. So you can use again this point and this point for the slope. Okay. So you can see the slope is 0 minus 100 because final x is 0 and the initial x is 100 in a time of 10 to 15 seconds. So that is 15 minus 10. We are using that formula of slope, y2 minus y1 upon x2 minus x1. Here y is meters displacement and x is time seconds. So it's becoming how much? It's becoming minus 100 by 5, or it is becoming minus 20. Like many of you have given the correct answer, it is minus 20 meters per second. So the instant velocity is magnitude, sorry, the instant velocity is value at 12 seconds is in fact minus 20 meters per second. Alright people, so hope this is clear to you. So I will just minimize this a bit so that you can see all these parts. Okay, so everything from the concept required in this question right up to the actual solution, that is this thing. Okay. So just do a quick review of this and then we are moving on next to question number 2, let us do. That's also an interesting problem. So all the subjective questions I'll be discussing, whereas the objective ones I will be mostly giving you hints how to solve. You continue trying them, and if you have difficulty, you can contact me on WhatsApp and I'll help you out. Okay. All right, so hope this is clear. So now I'd like you all to just go through the second question for a moment, okay, while I refresh my screen, and I'll put up the question right about now. So just go through the question and understand the language of it. In the second question, notice what is happening is you are given instead, you are given a velocity versus time graph. In the first question, we had a position versus time graph. So what is the difference of velocity versus time graph? Velocity versus time graph में हम slope से क्या निकालेंगे? Acceleration. Whereas हम displacement कैसे निकालेंगे? From area under. So that is the concept we have to use. So let us look at this question now. Okay. So in our velocity versus time graph, you can see that the velocity is having both positive and negative values. That means the direction of motion is switching. Now, anytime we have a one-dimensional motion where the velocity is positive for some part and again negative for some part, we understand that the direction of motion must be switching. And that is what is happening over here, in fact. Okay. So let us observe the graph exactly. So it's something like two triangles kind of thing. So from 0, the velocity goes like this, let's say. Let's say it becomes like this. And then finally, okay, so this is somewhat of what is given over here. And at this point of time, the velocity is plus 5 in meters per second. And at this point of time below here, so roughly this value, it is minus 5 meters per second. And also given to us is that this time is 20 seconds and this time is 40 seconds. So these are the values of time. Now it says that the velocity time graph, find the distance traveled by the particle during 40 seconds. Also find the average velocity during this period. Okay. So we have to calculate the distance. So remember what is happening. The distance will be equal to magnitude of displacement, okay, when the direction is fixed. Otherwise, we cannot say that. Okay. Otherwise, what is happening? Otherwise, the distance becomes greater than magnitude of displacement because the direction is switching. So here, where is the direction switching? That is the important thing to understand in the question. The direction is only switching once. When the velocity is, so in this part of the graph, 0 to 20 seconds, you can see that velocity is positive. Okay, so that means whatever person is moving, their direction of motion is along positive direction or the positive x-axis over there. Okay, whereas what is happening from 20 to 40 seconds, from the graph you can see that the velocity's value is negative. So the velocity's value is negative. That means what is the direction of motion looking like? It's looking like this. So the direction of motion is along the negative direction. Okay. So that means if I calculate the distance traveled from 0 to 10 seconds, I can say it is magnitude of displacement from 0 to 10. If I separately calculate the distance traveled from 10 to 20 seconds, I can say it is magnitude of the displacement from 10 to 20 seconds. But if I calculate distance from 0 to 20 seconds, it is not equal to displacement's magnitude from 0 to 20, because in 0 to 20, once in between at 10 seconds, what is happening? The direction is changing. So we have to be very mindful of this factor. So hope this part is clear to all of you. Okay, so that's one concept we'll be using. The second concept we'll be using is that displacement is area under the graph. It is area under the velocity versus time graph. So just use this concept now and try to figure this out. So what we have to do to calibrate the distance traveled in the total 0 to 20, we have to break it up. We have to break it up as it is the distance traveled separately from 0 to 10 plus the distance traveled separately from 10 to 20. And then we can calculate this as magnitude of displacement from 0 to 10, and then separately this as magnitude of displacement from 10 to 20. Okay. So this is basically going to come from, so displacement from 0 to 10 is the area, let's say E or E1, and displacement from 0 to 20 similarly, sorry, from 10 to 20 similarly is, let us say, the area E2. So going back in my graph, what are the areas A1 and A2? This area here, this one would be A1. That is the displacement from 0 to 10. And similarly, this area here, this area would be A2. And that is the displacement from 10 to 20. So you can see that this area will be a negative quantity because it's coming on the negative side. This area would be a positive quantity. It's a little bit odd. You people are not used to thinking of area as a negative or a positive quantity. But when we are thinking of area under a graph, if we think of it as multiplication of this value with this value, you can see here the value is positive. No? So this is a positive area, whereas here the value is negative. So it's a negative value into this. So it has to be negative area. Okay. And now we can calculate how much it is. So it is positive of half into base. So the base is 20 seconds into the height, which is 5 meters per second. So that is how this is becoming. How much is becoming positive of half of 20 into 5 is 50. Okay, so positive 50 meters. And likewise, you'll see that this area here will be negative of the area. So half of base again, which is 20 to 40, so that's 20 again, but into the height, which is 5. Or if you want to write this another way, you can say it is half into base into the height, but the height is a negative quantity. So that's how the minus sign comes. So it is in fact minus 50 meters. Okay. So that is why you can see another interesting thing. The net displacement will be 0. So what the body would have done is it would have started from here, let's say at t equal to 0. Okay. And then at 10 seconds, it's reached here, let's say. Or rather 20 seconds, it's reached x equal to how much? This total displacement. So that was 50. Okay. And then what is happening after that? It is turning back. So now it is going back like this. And then again coming back here at 10 because the net displacement is 0. So this is at a time greater than 20 seconds. And this one here was at a time before 20 seconds. So up to 20 seconds is going like this. Then after 20 seconds is coming like this, such that he reaches again where he started from at the final time, which is whatever t equal to 40 seconds. This one. So he's back to where he started. So this is how the motion looks. He goes from x equal to 0 to x equal to 50 and then back. So that is the interpretation of the displacement. Okay, so just make sure you understand this graph thing properly once. Then I will take you to the distance covered. Yes, Adina, that's correct. Okay, so you can now just go ahead and add the magnitudes of the two displacements. So 50 plus again mod of minus 50, so that's 100 meters. Whereas if I ask you what is the displacement from 0 to 40, the answer is 0. Okay, we will so hope it's clear up to this. So now continuing from this point, we can see that so far what we've understood is that the displacement from Okay, people, I will just so resuming the recording. Yeah, so in the third question, what you will notice is what is given to me is that there is total time of 25 seconds, right? That is given to me. And the other information that is given to me that out of 25 seconds, for some period of time in the beginning, there is uniform acceleration. Then some period of time in the end, there is uniform deceleration. Whereas for some time interval in between, there is uniform motion. And so you can break up the time like this, that let's say 0 to t1, there is uniform acceleration. Then t1 to t2, the velocity is uniform, so acceleration is 0. And then finally t2 to the final time, which is 25 seconds, there is uniform deceleration. So now your journey is divided in 3 parts. 0 to t1, uniform acceleration. Then t1 to t2, uniform velocity. And t2 to t3, which is 25 seconds, uniform deceleration. So we are getting somewhere more now. Now the problem is we don't have an idea about the value of t1 and t2. And we don't have the idea about how much velocity is the uniform velocity. Notice that the value given to you in the question is not the value of the uniform velocity. It is the average velocity for the entire journey. That 72 kilometers per hour is not the velocity during that time when the velocity is uniform. Contrary to that, it is in fact the average velocity. So that means there is some hidden information there. What is the hidden information that is over there? Average velocity से हम total displacement निकाल सकते हैं क्या? Can we find what is the total displacement from the value of average velocity? Just think about that. So you'll realize that we can do that. Now, average velocity multiplied by time, which is given to me as 25 seconds, will tell you what the total displacement is. That means the displacement during the first t1 seconds, then from t1 to t2, and then from t2 to 25 seconds. That total, the sum of those three is how much? It is equal to average velocity multiplied by time. So now that is what I have to use to find out the value of t1 and t2. Okay. Now a small hint to you, this type of question is always easier to work out when you think in terms of graph. So instead of trying to substitute the information I've given you directly in equations, what you do is you draw which graph? The velocity time graph. So try to visualize the velocity time graph for the given motion. And in that time graph, velocity time graph, label T1, T2, which I've told you, and try to see in terms of T1, T2 and all, how we will find out the total displacement, and the total displacement's value is given to us. Okay. So just start with this. So I'm putting up the graph in just a moment. But in the meantime, just try this yourself. Try to draw the velocity time graph. Right. So try to draw the velocity time graph, making use of the information which I've just told you. Right. So you will be getting the whiteboard online, as you can see now. Okay. So let me just put up the information given in the question. So question number 3. It is given to me that p equal to 0 to some time t1, which I don't know. The acceleration is plus 5 meters per second, and it's starting from rest. Okay. Then from t equal to t1, which I don't know, to some time t equal to t2, the acceleration is 0, or it is having uniform velocity. So that is what we mean by uniform motion. Uniform motion is motion with uniform velocity. It should not be confused with uniform acceleration. Whenever the motion is having uniform acceleration, we say uniformly accelerated motion. We never say uniform motion. We say uniformly accelerated motion. So that is what is happening in the first part. Whereas whenever the motion is happening with 0 acceleration, or the velocity is uniform, then we just use the term uniform motion. So the term uniform motion, you should always remember, refers to a situation where velocity is constant. And then finally, from now T2 also I don't know. Okay. And this uniform velocity's value also I don't know, because I don't know T1. And then finally, from T equal to T2 to T equal to 25 seconds, this value I know. So during this final time, what is happening? The deceleration is 5 meters per second square. So the acceleration will come with a minus sign like this. Okay, and also given that the average velocity for the entire journey, that is 0 to 25 seconds, that is equal to 72 kilometers per hour. Okay. This is, and it's also given to me that finally it comes to rest. So let us figure out first of all what this information is giving. Okay. So average velocity, which is 72, so I'll convert that 5 by 18. So that is 20 meters per second. Now this average velocity is equal to what? Total displacement upon total time. Okay. So that means the total displacement from 0 to 25 seconds is the average velocity, which is 20 meters per second, into the total time, which is 25 seconds. Okay. I'm just making use of this definition now. So that is how much it is: 500 meters or 0.5 kilometers. So this is the extra information which I'm generating from what? I'm generating it from this. Okay. So here I'm using a trick. The trick that I'm using is that we can always use this thing that displacement is equal to average velocity into time. This will take that. Okay. So now let us think from this. How will I find T1 and T2? And from that, I'll get the uniform velocity. The part of the motion which is uniform between T1 and T2. How will I get that? This is what I have to think next. Okay. So what you can think now is either you can convert this information to equations, which will become very tedious, or you can convert it to a graph, which will be somewhat less tedious. So the advice to you is always in this type of situation where you have uniform acceleration, then uniform deceleration and things like that, and the total displacement is known to you. You can always make use of the graph trick that if I know my velocity time graph, the displacement is area under the graph. It will always be easier to analyze it from area under the graph rather than analyze it from the formula. Alright. So next thing what you try to do is you try to plot yourself the velocity versus time graph and try to see what information you can extract from that. Okay. Is there any symmetry in that? Is there any trick that we can use in that? So I'm putting it up in a moment, but you figure it out yourself. Okay. So let me just put up the what looks like the logical version of the graph. This is my velocity versus time. And let's keep all the units. And here there's no question of the velocity going negative because it says it starts from rest, then comes back to rest. It never says it's going negative. So that's why I've not drawn the negative part of the graph, where velocity could be negative. So this is in seconds. So here what is happening is that initially there's uniform acceleration. So there should be some kind of a slope. Let's say it's like this. Then it's going at uniform velocity for some time. Then it's having the same amount of deceleration. So that is the key to understanding the question, that the amount of deceleration in the third part of the motion is the same as the amount of acceleration in the first part. So that is where when I look at this time in my graph is T1. And this time in my graph is T2. And this is T3 or 25 seconds. And also, this value of velocity is unknown to me, but this is the uniform velocity V that is. Now, what other information I know? That during this part of time, the acceleration is +5. meters per second square. That's a piece of information I have. And during this part of time, the acceleration is -5 meters per second square. Okay. So the first thing that we'll understand symmetry wise over here is that because the value of this acceleration is the same as the value of this deceleration, so I can say that this interval of time, whatever delta t, let's say, will be equal to this interval of time, delta t. So now I can reduce the number of variables. T1 अगर delta t है, तो T2 कितना हो जाएगा? It will be 25 seconds minus delta t. Okay, this is what I'm understanding from the symmetry. Is the symmetry clear to all of you? See over here, the equation will be what? For this part, the equation will be equal to V, which is equal to U, which is 0, plus 5 into T. So that's T1, or 5 delta T. Now here, for this part, what will be the equation? The final velocity is 0. The initial velocity is V minus 5 into delta T. So we have that 0 is equal to V minus 5 into T2 minus 25. So it is by comparing these two, this equation here and this equation here, you understand that the delta T of this part is equal to the delta T of this part. So this is very critical to understanding the shortcut that we are getting in this part. Okay. That's one thing. Okay. Now what is the other information we have about the graph? Okay. Also, we know that the total displacement from 0 to 25 is how much? It was 500 meters that we got from above, from the average velocity. So that means the total area is equal to 500 meters. Okay. So let's make use of this. So in the total area, let us say this area plus this area plus this area is that. So the area of triangle 1 plus the rectangle in between plus the second triangle, that area should be equal to 500. Okay. So let's calculate now the area. So the triangle 1 के लिए base कितना है? Delta t है, और height कितना है? V है. Okay. Triangle 2 के लिए what is the length? It is V, and what is the base? Now it's this value T2 minus T1. Now T2 minus T1, you will also see because of this T2 minus T1 will become equal to 25 minus 2 times delta T. So this thing I will currently write as T2 minus T1, but later I'll substitute it. Okay. Just tidy this up a little. So the area of this rectangle is becoming the constant velocity into the time interval, which is T2 minus T1. And later I'll import this value of T2 minus T1. Plus the second triangle, which is again the same as the first triangle, plus half base into height. So this all should be equal to 500. Okay. So this is the equation I've got so far. Now you can see in this equation I still have two variables. V is there and delta t is there. And of course T2 minus T1 I'll substitute. Okay. So I have to reduce it to one variable. So also we can see that V is equal to how much? It is delta t. I mean 5 delta t. Acceleration into delta t. V is equal to, the properly written you can see it is AT1. Okay. So that is 5 delta. So this is like the first equation that we are writing from the area, and this is the second equation that we are writing from this factor. And this V equal to U plus AT, or even for the final one, final velocity V is equal to initial velocity minus 5 into the time interval. So from that we can replace V with 5 delta. So do that in the above equation. So substitute this in equation 1, okay, and you will now get this equation, that 5 times delta t whole square हो जाएगा divided by 2, that's the area of the triangle, plus the velocity, which is 5 delta t, into that time interval, which is 25 minus 2 times delta t. Okay, that's this one. Plus again the same thing, 5 delta t whole square by 2. This should be equal to 500. So as you can see, this is now a quadratic equation in delta t. So from this we will calculate delta t. And once we calculate delta t, our uniform velocity v for the in-between part will become 5 delta t. So we'll be able to calculate that also. So that's why I told you that this is a bit of a tricky question, because first of all there is some understanding of how to use the graph and all that, and then there's also solving a quadratic equation involved. So just do this step by step. So first I'll minimize this for you people so that you can understand the full logic of the symmetry of the graph and everything. Take your time, don't worry. These are questions which are for us to learn a lot of things together. In the same question, we are learning about kinematics, we are learning about the symmetry of graphs, and then finally we are also going to learn how to. So we'll come to solving equation 1 and 2 further below. First of all, from here right now, just understand how we have come to equation 1 and 2. So how we have used the information earlier, this information, how we have converted this information. So I'll just leave you with this for a moment, then I'll come down below to the graph. So as I told you, this information has to be converted into a graph. KP. Good morning. Okay, people, so I'll scroll down below to show you how we converted this information into graph. And within the graph only, you can see how I've used the symmetry of the graph. So then understand the graph, and then from there understand how we come to equations, these equations below. Okay, but first understand the graph. Uniform acceleration for some time t1, then uniform motion for some time up to t2, and then uniform deceleration till it comes to rest again. The total time is 25 seconds, but in between, to begin with, we don't know these two times, t1 and t2. But because we realize that ये जो acceleration है positive 5, its magnitude is the same as the deceleration here, which is -5. So it takes the same amount of time to accelerate to this velocity v as it takes later to decelerate from v to 0, because the rate of acceleration is the same as the rate of deceleration. So that key is telling us this thing, that this interval of time delta t from 0 to t1 must be equal to this interval of time delta t from t2 to 25. So that's how we are learning that if t1 is delta t, then t2 must be 25 minus delta t, because t2 to 25 must be the same amount of time as 0 to t1. So with that, you can now see that this triangle here and the last triangle here are congruent triangles, whereas in between you have the rectangle, and the total displacement is the total area under this graph. So that total displacement being 500 meters, because it is average velocity multiplied by time, you can see that that should be equal to the first triangle plus the second triangle plus the rectangle in between. So that's how we come to equation 1. And then it's just a matter of substitution from v equal to u plus 18 to remove the variable of v from that equation. And finally, we will get the value of time. Okay, so next step, make sure you understand the graph, and from the graph how we have generated equation 1 and 2. Then we'll talk about the solution of equation 1 and 2. value को substitute कर दिया in equation. So from here I've used, from equation 1 I've used the fact that v is equal to 5 delta t. I've substituted that in equation 1. That thing is going to this. All right, so let's just tidy this up and get the final quadratic equation that we have to solve. So on substitution, this is what we're getting. So add these two, so it will become 5 delta t square. Okay. Then you have another thing. So you have, just let me take delta t square common. Just solve this out. So the delta t square term has from here 5 by 2. Then from here how much? Minus 10. 5 delta t into minus, okay. And then again 5 by 2. So does this, okay, plus 50 delta t. Oh, sorry, 125 delta t. My mistake. So the product term here is 5 into 25, so 125. So 125 delta t. On the other side is 500. So another thing very convenient you are seeing over here, that just so happens that this and this are cancelling. The delta t square term, 5 by 2 plus 5 by 2, that's 10, minus 10 is cancelling out. Okay. So ultimately we are left with what? We are just left with this term. 125 delta t is equal to 500, or delta t so 25 goes 5 times, 25 goes 20 times, or 4. Okay. So you can see that my delta t is coming out to be 4 seconds. That means that t1 was 4 seconds, then t2 was 25 minus 4, so 21 seconds, and then finally the time t3 was 25 seconds. So what is happening is, finally we are understanding that from 0 to 4 seconds we are having uniform acceleration of plus 5 meters per second square, and therefore the velocity is going from initial 0 to the value of 80. So that is 5 for the 20 meters per second. But this is also telling me that that velocity we get is 20 meters per second. Okay. Then what is happening is, from 4 to 21 seconds, that is t1 to t2, we have uniform velocity, which is equal to that 20 meters per second, and acceleration 0. And then again from 21 to 25 seconds, we are having uniform deceleration. Okay. Which is giving us velocity going from 20 to 0. So this all information is there in the graph, actually, you can see. So I will just minimize the solving of the quadratic equation. So this was only the above quadratic equation. Okay. So not to get too bogged down by long questions like this, which require quite a bit of patience and solving and all that. Just step by step get into the habit of analyzing the question and taking your time, but doing the steps accurately. That is the most important thing here. The whole purpose of part of these classes is to get you used to solving lengthier questions systematically and with patience. Yeah, let's go. Oh, I made a mistake with it. Yes. People just hang on. We have to recheck my equations here. This is not going to give a 0. Sorry, my mistake. So here onwards, it's not correct. Okay, let me look at this part again. Okay, let's just look at this part again. So what is this giving me actually? This is giving me 5 by 2 plus 5 by 2, which is 5 minus 10. So sorry, that is 5 minus 10 or minus 5 delta t square, okay, plus 125 delta t. So it seems that we will have to solve the quadratic equation after all. Is equal to 500. So you can divide both sides by 5. So minus delta t square plus 25 delta t is equal to 100. Or we can say that delta t square minus 25 delta t plus 100 is equal to 0. Correct? Okay, so just solve this for delta t. See what you get. Use the discriminant method. You don't need to factorize on it. Okay, so just ignore the earlier solution. Yes, very good. You will get one negative root actually. So eliminate the negative. For delta t, you will get one negative root and one positive root. So this is an equation of this type. X square minus 25x plus 100 is equal to 0. Okay. You can think of it like ax square plus bx plus c is equal to 0, where a is 1, b is minus 25, and c is 100, and x is basically delta t, like that. So x is equal to what? Minus b, so that is plus 25 over here, plus minus root of b square, so that's 25 square, minus 4ac, so that's 400, divided by 2a, so that is 2. So it is 25 plus minus root of 625 minus 400, which is 225, which square root is 15. So this is 25 plus minus 15 divided by 2. So one root becomes 25 plus 15, so that is how much? 40 divided by 2, so 20. And the other root becomes 25 minus 15, so that is 10 divided by 2, which is 5 cents. So sorry, one root doesn't come out negative here, but we still have to analyze which is my T1 and which is my T2. So now remember, T1 is delta T, suppose, and T2 is 25 minus delta T. Okay. Now you'll see that if I use 20, if I use delta T equal to 20 seconds, I'll get T2 as a negative time. There is a negative root in that sense, and that's not acceptable. So that is why this root becomes unacceptable. So that is why this root gets eliminated for this. Whereas if I use delta t as the 5-second root, then you can see that T1 is 5 and T2 is 20. So that is an acceptable solution. So that is why final solution that we accept here, I mean, even though we are not getting a negative root, but it is having an implication that, you know, some kind of time is coming negative. And in this case, the value of T2 is the time which is coming negative. So that is not acceptable for us. So that is why we rule out this option, because this is not. So we take this route, the positive. So finally my t1 is 5 seconds, t2 is 20 seconds, and from that you can see that the velocity is 5 into t1, 5 delta t, so that's 25 meters. This is the uniform velocity from t1 to t2, that uniform. Okay. So I'll just minimize this once more for people to fully go through. I'm hoping that it's okay when I minimize to this level. You're able to still understand from the screen resolution. How is T2 coming out to be 20 meter? Because see, earlier you had seen that relationship between T2 and delta T क्या है? वो यहाँ पे. This relationship. This. So these two relationships. So anyway, so last we had seen up to this quadratic relation that we had, then we started with solving it properly. So that's over here. So that roughly is the solution of this question. Yes, Dhruv, you have any doubt or something? You just go to the chats. So Mohammed, I have answered your chat, your answer. Adinath, yes, your answers are correct. Achha, Dhruv, you were talking about that minus 25 thing. Okay. So it's clear now, I hope. Okay. So now this was the third question. Let's move on to the fourth one. So fourth is relatively simpler. It's like a version of the third question, but it's relatively simpler. So I would like you people, in case you haven't done the fourth question, just make the graph of it and try to solve it by the same method. So I'm giving you a couple of minutes to try out this yourself. So Dhruv, you have some other question or? Could I explain why it was plus 25 and not minus 25? Which thing was plus 25? The you're talking about the time? Acha, in the this thing. Oh, okay. In the equation solving, I understood. Okay, so I'll just explain the equation solving here briefly. So the equation solving is like this. This is your quadratic equation. That if we have the equation ax square plus bx plus c is equal to 0, then the roots of the equation, which we typically call alpha and beta, they are given by alpha is equal to minus b plus square root of discriminant divided by 2a, and beta is given by minus b minus root of discriminant divided by 2a, where the discriminant is defined as b square minus 4ac. So this is the principle we should know. Yeah. So see what b is now. B is minus 25 now. So minus b will become that. So the roots in general, you can write like this, are minus b plus or minus root of b square minus 4ac divided by 2. Now in this equation, what are the values we are substituting? Now see from here, we are substituting a as plus 1, but b as minus 25. So this minus b will become minus of minus 25. That's why. Whereas c is equal to plus 100. Yeah, you can do it by factorization. You can see that this one, this equation that we have, or the other thing is you can see by factorization, x square minus 25x plus 100 is equal to 0 is also equal to x minus 20 into x minus 5 is equal to 0. So that's fine. This is also okay. So this method is also there. This method, you can substitute this here. Okay, so hope that resolves this issue over here. Okay. Good. Okay. So when you are substituting that Bhattacharya formula, that discriminant one, you have to be very, very careful about the signs. Remember, it's very easy to make a mistake in the sign of either 4ac or minus b in the beginning and totally get the wrong roots. So it's a good idea that when you finally get the roots, just substitute them in the equation and check. No? So put 20 in the equation, you'll see left hand side is 0. Put 5 in the equation and you'll see left hand side is 0. Alright, so that's a good idea to always check up on yourself that way. Alright, people. So now let me put up the information about equation 4 for you. I mean question 4 for you as you're solving it yourself, and you try it out for a moment yourself, then I'll put it up if required. So it says in question 4 next that we have a motion along a straight line. So a train starts from rest and moves with constant acceleration of 2 meters per second square for half a minute, and then brakes are applied and the train comes to rest in 1 minute. Okay. So what is happening is that, let's say it starts from rest. Screen resolution, right? So let's say this is our train. It starts from rest at t equal to 0. Okay. And then what is happening is it's going for half a minute. So let's say it reaches somewhere here at t equal to 30 seconds. It reaches here with some kind of velocity, which we can find out. Okay. But importantly, while it is going here, it is having a uniform acceleration of plus 2 meters per second. Now thereafter what is happening? It starts decelerating. So after this 30 seconds, it starts decelerating. So with sign convention, the acceleration is negative of something, some value. Okay. But the further information that is given to us that finally it comes to rest after another 1 minute. It says it decelerates for 1 minute and comes to rest. So if it decelerates for 1 whole minute, that means by the time it comes to rest, what is the total time? It is not 1 minute. Here, when the velocity again becomes 0, what about the time? The time is 90 seconds. Because from here to here, this is 1 minute. Okay. Whereas from here to here, this is happening in 30 seconds. So that is why if the time was 0 here, it's 30 seconds here, here it is almost 90 seconds. So from this, we have to find the total displacement of the train. And the maximum speed. And various things. Okay, distance traveled, maximum speed, and the positions when the train is at half the maximum speed. So we have to find the total distance, which will be the total displacement over here. Then we have to find the maximum speed, or in this case you can say velocity, the train will achieve. And we have to find S when V is equal to half of So this is just the information of the question. I have not given you any solution yet. Now what I'm asking you to do is convert this information into graph. Okay, Bhaumik. Yeah, Bhaumik, I'll explain the graph, but I'm just asking you to refer to the graph of the previous question if possible, or even the graph of the second question we did earlier today and all that, and from that try to understand how the velocity versus time graph is. Okay, so make V versus T graph. Okay, try to do this. The diagram is just according to the information of the question. Read the question carefully. Have the worksheet in front of you. You'll understand what it is. 0 से 30 seconds वो uniformly accelerate कर रहा है, and then for another 1 minute वो uniformly decelerate कर रहा है, and finally coming to rest. That is what I've shown you in the diagram. Okay, so convert the information of this diagram into a graph. Okay, so just try this out, people. Yeah, Ajinath, I think your answer is just correct. If you just if you can verify it with the answer key, which is given also. So anyway, let's. So let's try and draw a velocity time graph and see what information we get from that. So the body is starting from rest and it is having uniform acceleration. So let's label that part of the diagram with like this. So during this time, the acceleration is plus 2 meters per second square. That information is given to us, and this time is 30 seconds. So that additional time is information is given to us. So from that you will see we'll be able to find out what this velocity is, what the value of this velocity, which in fact will be the maximum velocity, because after this it starts decelerating. Okay. So you can see that V max will be equal to this uniform acceleration into time. So it will be 2 into 30, it will be 60 meters per second. Okay. Now the second part of the graph is decelerating such that it comes to rest in 1 minute. So from here you go another full minute. So if I want to draw the graph exactly, I think this should be correct. I mean, there's no obligation that actually another box. So in the interest of making a ultra correct kind of graph, it will look like. So during this time, you can see that the acceleration, let's say I'm calling it A prime now, that is going to be minus of something. But I know that this time is 90 seconds because this time interval from here to here, that is given to me. That is 1 minute. So that's also something you have to pick up from the language of the question. That is not that the time is 1 minute. It is the time it decelerates for. That is 1 minute. So this is half a minute. It accelerates for half a minute and then decelerates for half a minute. So now you'll just realize by symmetry or just from the slope of the graph what this value is. Okay. This E prime will come out to be minus of 1 meters per second. You can just use the relation V is equal to U plus AT for that, or the slope of the graph, or you can just understand that time double ho gaya, but change in velocity same hai. So magnitude of acceleration should be half. Okay. But more importantly, we have got our Vmax. Okay. And now as far as the displacement is concerned, the displacement from 0 to 90 seconds is area, the total area. You can just use that. You don't even need to break it into 0 to 30 and 30 to 90. You can do that only. So that total area is half into base, which is 90 seconds, into height, which is the maximum speed. So it's half into 90 into 60, and this will be meters. Because 2.7 kilometers. This is going to be the total displacement. So just now we still have to find the other thing, that what is the displacement at the time when the velocity is half the maximum value. Maximum velocity to pehle aap calculate this one. Okay, so now just figure out from the graph how you will get the time. Just plot the horizontal line that is standing for Vmax by 2, or that Vmax is 60. So draw a horizontal line on the graph which stands for V equal to 30 meters per second, and see where that horizontal line cuts the given graph of the motion. We'll cut it at 2 different times, one while it was accelerating, one while it was decelerating, and from that we can find the displacements. Okay, so hope so far this is clear. Now let's come to the last part of the question where we want to find out the displacements at the time when this is happening. We want to find out that what is the displacement when the velocity is half the maximum velocity. So let's focus on this graph for a minute. So you can see that this maximum velocity we had calculated just now, this was 60 meters per second. So now the velocity that we are talking about, let's say it's over here. This is 30 meters per second. That's half the maximum velocity. So this will cut this graph at two different times. This is not a motion graph or anything, it's just a guideline. So we are talking about two different instants of time. We are talking about one instant of time, which is somewhere over here t1, and we are talking about one instant of time somewhere over here t2. Okay. Now, so the first thing is I need to find out t1 and t2, and from that then I can find the displacement. तो अभी t1 देखो कैसे निकालेंगे? We'll just use this line's property, that is slope is equal to this much. Its slope is equal to the acceleration, which is, so you can see here, you can just use similarity of triangle also. 30 seconds में velocity कितना हो रहा है? 60. तो कितने सेकंड बाद 30 हुआ होगा? This must be 30 by 2. This must be 15 seconds. So this is how we use it. So here for T1, I'm just basically using this concept that E into T1 should be V max by 2, and I have E into 30 seconds is equal to that V max. So just compare these two equations. So this equation A and B. So from comparison, you will get that T1 is 15 seconds. Understood this? Now, like that, you tell me how much should be T2. Work it out and tell me how much should be T2. Alright, so tell me how I'll get T2. So again, use the property of that second straight line. ना ये जो red वाला line है, उसमें क्या हो रहा है? The velocity is decreasing from 60 to 0 in 1 minute. So how much time it will take to decrease from 60 to 30? Half a minute. That means this interval of time from 30 to T2 should be how much? It should be 30 seconds. So that means T2 should be how much? It should be 1 minute. This should be 60 seconds or 1 minute. Again, this time should be the midpoint of 30 seconds and 90 seconds. That's another way to understand. Alright, so how I'm getting the T2 like this is, see, again, so again see, from t equal to 30 seconds to t equal to 90 seconds, the velocity drops uniformly from 60 meters per second to 0. Okay. Therefore, v is equal to 30 meters per second, that is v max by 2 at t2 equal to 30 plus 90 by 2. Yes. So you can just visualize this like this, that the velocity is dropping. Let's make this better. So forget about the first part of the graph. The second part of the graph, the velocity is dropping like this uniformly from 60 to 0 in time 30 seconds to 1 minute to 90 seconds. Okay. So obviously it will reach the half point at the midpoint of this. It will reach 30. So this T2. So T2 will be the midpoint of 30 and 90. That's how I got this. So the job is not done yet. We have just got the time. Now we have to get the displacements. Yes, so Bhomik, I have explained that point only. Okay. Now we want to calculate the displacements. We want to find displacement at t equal to t1, which we had calculated earlier as how much? 15 seconds. Okay. So that will come from the area. So now we have to go back to that part of the graph. Okay. So that part of the graph was like this. This was 60. Somewhere here was 30. Correspondingly, this time was 15 seconds. So I have to calculate this area to get this. So that area is half base into height. So 225 meters. So that is the displacement at the first instant when the velocity becomes 30 meters per second. Okay. Now similarly, we have to find the displacement at this time t2 also. So I'm coming to that. But first note this down. And if you understood this already, then you can just figure out the second thing yourself. So I'm minimizing this a little for you to follow the whole thing. Yes, Saurabh, I think your answer is correct for the second part also. Just cross check it with the answer key. Okay, people, so hope this part is clear. Now let's move on to the final part where we want to find the displacement. We want to find the displacement at P2 equal to 60 seconds. We want to find out that. So that also we do from area under the graph. But you see, we can use a small trick over here to calculate the relevant area because we've already got the total area before. You can make use of that information. Something like this. Right. So my values in this graph were like this. So this value of velocity was 60, which was the maximum, and it occurred at a time of 30 seconds. This time was 90 seconds, and we were now more interested in this point of time, let's say over here, where the time is 60 seconds. Okay. So now the displacement we are talking about, displacement in 60 seconds, this is from area, this one. This total area we want to get. This area we want to get. So this area we can also calculate by trick that the given area is equal to total area minus, let's say, E prime. So that was the small little trick I was doing, that we don't need to do so much mathematics here. We can just calculate this area as E prime and then just subtract that from the total area. So the total area earlier only we had calculated was 2.7 kilometers, so 2700 minus the area of that small triangle there. The area of that small triangle, the base you can see is 30 seconds and the height you can see is 30 meters per second. So that's 2700 minus 900 by 2, so that is 450. So that is how much? That is 2250 meters. So this is this area. So this is my displacement from 0 to 60 seconds. This should become an answer. Okay. So this is the very interesting solution of the last part of the question. So hope this is clear to you people. Okay, people. So I'm just taking a relook at the worksheet. So now for the remainder of the questions, I'll just give you some hints. But actually, they're all more or less based on these concepts that we've discussed till now. And I'll also tell you a little bit about how to prepare for your upcoming test. That's also important from today's lecture's point of view. Don't worry about that at all. It will be very simple. It will be based on the kind of things we've been doing in the whiteboards in class. So if you just revise most of the questions from your whiteboard notes only, it should be a good preparation for you. So I'm just stopping the screen share for a moment. So fifth question, just go through it in your assignment. So I'm reading it out. So it says that a driver takes, there's a small misprint over here. It should not be a drive takes, it should be a driver takes. So the question says a driver takes 0.2 seconds to apply the brakes after he sees the need for it. So let's understand what this statement means. This is actually related to what we call reaction time. What this means is that if you see that there's something that has suddenly come in front of you while you're driving, or there's a turn or something, and you realize you need to brake, there's a small time gap between when you realize it in your head and when your foot actually pushes the pedal. So that is called the reaction time of the driver. For race car drivers, this reaction time is an amazingly short amount of time. For normal human beings like us, it might be a longer period of time. So it varies from person to person. So this particular driver, he has a reaction time of 0.2 seconds, right? 0.2 seconds is the reaction time. And on this particular instance, his car was traveling at 54 kilometers per hour, or that is 15 meters per second, 1.5. Okay. And once he brakes, let's say he pushes the pedal of the brake fully. So the rate of deceleration that he brakes at, that is equal to this thing, 6 meters per second square. And he brakes till he comes to a rest, comes to a halt completely. And we have to find the total displacement and the total time taken, let's say, on that. So what we have to understand is that from the moment he decides, then please get hold of it for me, because I mean it's not. This is how we proceed. You should have the worksheet in front of you. I've sent it to you multiple times actually. Right. So what is happening is that you have to calculate the total displacement. So now visualize from the time he decides to brake till he stops, what is his motion looking like? So this is what his motion is basically looking like. That let's say he decided at time t equal to 0 that he wants to brake. So again, I will visualize this in terms of a velocity time graph. So at t equal to 0, he decided he has to brake. Okay. So how much time it takes for the brakes to actually engage? It takes 0.2 seconds. Because that much time is what we call his reaction time. So during that much time, what is happening? His velocity is uniform. Because the brakes start applying only when his reaction time is occurred. So during this interval of time, he is traveling at the constant speed of 54 kilometers per hour. Or that is the same thing as 15 meters per second. And then the actual brakes come into action. Okay. And when the brakes come into action, it creates a uniform deceleration till he comes to rest. So it takes a uniform deceleration till he comes to rest like this. And that rate of deceleration is 6 meters per second. So it's minus 6. So you can see that from this time to this time, if the time here is some t1, we can see how much t1 will be. T1 will be 0.2 seconds plus a certain amount of time for which the actual braking has occurred. The braking has actually occurred for that much time. So how much is that time delta t? It is equal to the change in velocity upon acceleration. It is delta v by delta t. Sorry, delta v by acceleration, because that is how we define acceleration. It is change in velocity upon change in time. You can see the velocity has changed by minus 15, because it has gone from 0, sorry, it has gone from 15 meters per second to 0. So the change is minus 15. The velocity is dropped by 15 in a time interval of delta t, which we are trying to find out, but with a rate of deceleration of 6. So my delta t is how much? My delta t is equal to 15 by 6, so that is 5 by 2 or 2.5. Okay. So delta t is this much. That means what is this time t1? It is actually 2.7 seconds, because this interval from here to here, that only is this. Okay, so that's the time, and now you have to find the displacement. So for the displacement, you just calculate this total area. Okay. So this area will give you the distance or the displacement that it covers as he is coming to rest. So this is the very simple hint sort of thing I'm giving you for question number 5, and you will be able to work it out now. No difficulty. Okay. So just take a note of this if you like. You will have this on whiteboard also. Okay. Now coming back to the remaining questions. So sixth question you will see is fairly easy. You will be able to work it out. It says that car travels from A to B at 20 kilometers per hour and returns at 30 kilometers per hour. So you have to find the average speed. So average speed will just be total distance upon total time. So let us say the distance from A to B is some unknown quantity x. So the time taken to go from A to B will be how much? X by 20, displacement upon velocity. And then the time taken to come back will be again x by 30. So you write your time t1 as x by 20, and your second part of the journey t2, write the time as x by 30. So the total time is t1 plus t2, and the total distance traveled is how much? 2x. So total distance divided by total time, that is 2x divided by t1 plus t2, and you have written t1 and t2 in terms of x only. So that is how you'll be able to find the average velocity. Now, similarly, seventh question, total distance traveled is given to you. Now it says it covers first half of the distance at 40 kilometers per hour, and the second half at a velocity v, and the average is 48 kilometers per hour. Then what is the value of v? So again, here you have to follow the definition of average velocity. Average velocity is basically what? It is the total distance, I mean average speed in this case. What is the average speed? It is 2000 meters total distance divided by the total time t, which we don't know. Now how we'll calculate the total time? Again, divide the motion into 2 halves. The first half where he's traveling at 40, and the second half where he's traveling at an unknown velocity v. But don't forget to convert the 40 kilometers per hour into meters per second. So first half का time कितना हो जाएगा? 1000 meters divided by 40 kilometers per hour. So that will give you a t1, and your t2 will be how much? It will be the remaining 1000 meters divided by the unknown velocity v. Right? So you got t1 and t2 in terms of the velocity v. Now you write the average speed as what? The total distance, which is 4000 divided by t1 plus t2, and equate it to 48 kilometers per hour, and that will give you the unknown value of v. So that is the sixth question. Sorry, seventh. Okay. Eighth question is very similar to that. The method I told you in seventh question, similar method you apply in eighth. Okay. And ninth, in fact, is also the same. Okay. So I will just actually 8, 9, 10th are all very similar, and they are by the same method of 7th. So I will just do a quick discussion of one of these questions. And in my mind, the more tricky one is the 9th one. So I will just discuss the 9th question. Using the solution of the 9th question, you will be able to solve all the others, provided my whiteboard behaves itself. Just a moment. Okay, so just go through the statement of the 9th question. I'm putting up the method on the board. Now, this same method you can apply to all these questions. 7th, 8th, 9th, and 10th, all of these are very similar. Okay. So it says that total distance it covers is, let's say, d. Okay. Now it covers 1/3 of the distance. Okay. It covers at 10 kilometers per hour. Okay. 1/3 of the distance at 20 kilometers per hour. And the remaining 1/3 of the distance predictably at 30 kilometers per hour, or sorry, 60 kilometers per hour. Okay. And now from this, what we have to find is the average speed, not velocity, but the average speed. So how will we define the average speed? is defined as just a moment. So as per definition, average speed is basically what it is: total displacement upon total time. Just hang on a second, guys. My whiteboard software is hanging up for whatever reason. So just give me a second here. Okay, I'll have to restart my whiteboard software. Yeah. Okay. So this is what we talked about so far. Okay. Now we want to calculate. We want to calculate the average speed. So we see what is the definition of average speed. It is total distance upon total time. So what we do is total distance we have got d, but what about total time? So for this, let us say this part of the time journey takes t1 time, this part of the journey takes t2 time, and this part of the journey takes t3 time. So what is t1 now? It is speed, I mean distance, which is 1/3 of the total, divided by the speed, which is 10 kilometers per hour. What is t2? Just assume the distance is in kilometers. Okay, so this is in hours. So assume that the distance is in kilometers. So this time that we are getting is in hours. T2 is similarly d by 3 divided by 20. And similarly T3 is d by 3 divided by 60. And what about the total time? It is just T1 plus T2 plus T3. So now we will just make use of this. Okay. So the average speed is the total distance divided by the total time. So that is d divided by T1 plus T2 plus T3. So that is why, interestingly, though I don't know the total distance, I will not need it. It will cancel out. Because as you can see, you can take this common over here. This is 1 by 20. Is it? Or 1 by 10, sorry. So 1 by 10 for the first term, T1. Is it 1 by 10? No, it is divided by 1 by 10. So that 10 comes in the numerator. Understanding? It's d by 3 divided by 1 by 10. So it is like this. It is 1 upon 1 by 10. So eventually it will come in the numerator. Plus 1 upon. So eventually it will come in the numerator. But in the meantime, one thing you can do is you can cancel off the d's, take this 3 in the numerator, and then solve the denominator with LCM. So the LCM in the denominator is 60. You can see this is 6 plus 3 plus 1. So this is becoming 3 into 60 divided by, how much is this now? 10. So 18. And because everything was in kilometers and hours, this will come out to be in kilometers per hour. So that will become our average speed. Okay. So this, in a nutshell, is how we solve these type of questions. So the last 4 questions, actually, all of them can be solved by using this kind of concept. Right. So I'll just leave you with a minute to absorb this particular thing. Okay, Vamik, if you've not got the worksheet, then please make sure that you are logged on to the group, or for whatever reason, if you have not received it in the group or you are not able to download it from the group, then before the lecture, please drop me a message so that you have a copy of the worksheet. I will send it to you today. Best thing you can do is, can you drop me a private message on my WhatsApp? It's the same number as I am there in the group. On that number only, just drop me a private message saying that you have not got the worksheet, and I will send it to you.
Anytime it happens to any of you that you might not have got the link for some video, or you might not have got some worksheet, or you got it but it is not downloading or something, all these tech things can happen. So individually just message your teachers, they will send that same thing. Okay guys, so hope this is clear. That's it for the lecture today. Now before I conclude, I also want to talk about the upcoming test which you have on Sunday. So Sunday's test, I've only made the paper, so the questions are going to focus on motion along a straight line. So in the beginning, we had discussed a few general things like motion in 2 dimensions, and we had even done some questions of relative motion and all that. That was the first lecture, but that will not be included in this particular test. This test will be only that portion where we have systematically started kinematics. That is 2 lectures back. So today's lectures and the last 2 lectures, if you just go through the whiteboard notes and make sure that each and every question that we have solved on the board, you try that question out again or go through its solution again and understand it, that should be more than enough. And if you have any doubts or anything in those questions, then you discuss with me. Also, if you can go through the worksheets 1 and 2 very carefully, try and solve each and every question. And again, if you are having any difficulty with any of the steps, including some question which I may or may not have taught on the whiteboard, some of the questions I have not given you the full solution, so it could be that kind of question, or it could be something that I have given you the solution for also, but still you are having some difficulty. Don't hesitate to contact me immediately and make sure that all that is clear. If the techniques of the 2 worksheets and the last 3 lectures, that is today's lecture and the last 2 lectures, are 100% clear to you, there's no reason why you can't score 100% in the test. You're going to be able to score that, and pay attention to all the formulae and the graphs and everything, and you should do very well. Okay, that's it from me, guys. Hope you enjoyed today's lecture, and stay safe and stay happy, and help out your parents a little bit in the house, because it's a difficult time for all of us. Okay, that's it, guys. All the best.